I'm Kunal, and I'm a teacher with Urban Pro, and I have 2 years experience from my start, and I have teach physics, chemistry, mathematics, class 10th, 11th, 12th, and C, C++, Python languages, and Java also. And today we will learn about something electric field lines, and how does they work, what is the property of it. Hey guys, let's start our lecture or on the electric field. So our topic is all about on the electric field. What is electric field? How does that work? Okay. So our first topic is what is basically electric field. Okay. Basically the space around a charge, a particular charge that we know. Okay. And where test charge Q naught. We are supposing that there is a Q naught charge and it does not have a charge. We don't know about it, what charge it is have, and is placed, and it basically experience a force is called electric field. So let's demonstrate of the definition of the electric field. Suppose we have a charge, a positive charge, and the test charge plays at some distance, and we only know about that a positive charge, it is a positive, but not about the Q naught, which charge it contains. So we are testing that what charge it contains, the test charge, what charge it contains. Suppose when we place it near the positive charge, it attracts. What happened when it attracts? It means the Q naught is negative charge. What happened when it positive charge? They will repel. Okay, that's how we are testing it. So now what is electric field intensity? When a test charge plays an electric field, then the force at per unit charge is said to be an electric field intensity. And the formula basically is E is equals to force over Q naught. Force is electrostatic force, okay? And Q naught is a test charge that we are having. And it is basically represent the electric field intensity is represented by the E, and it is the vector form. So let's demonstrate it. Suppose I have a positive charge at the center, and it only experience, the test charge only experience some force only at the space around it, only at the particular limited space. Okay, suppose I am putting that test charge as far away from that circular thing, and it does not experience any force. If I will put that test charge on the circumference of that circle, or we can say around that space, so it will experience some force. So this is electric field intensity. So what is electric field lines? Electric field lines, like I told you in the previous slide, that these arrows are the electric field lines. Electric field lines, this line tell you that this is the charge who will experience a force or not, or it will tell you about the circumference, how far the circumference is, where you can experience some forces. So here's the electric field lines. These are the lines or the path along with the positive test charge which moves, it is free to do so in electric field. It means these in the previous slide I told you that these lines are the paths who decide that the circumference, or the they will decide that how much charge they will contain, or how far they will get. So these are the lines of electric field. So the properties of the electric field lines, they will start from the positive and to the negative. And these lines does not pass through a conductor which contain electricity. No? They cannot pass through that. So electric field lines never intersect each other, and it is only because suppose they are at a one circle, there are two electric field lines and they are intersecting each other. They will provide you the two directions, and if a same thing provide you a two direction, it is never possible. That's why electric field lines never intersect each other, and that's the point there. If they intersect each other, so they will provide you the two directions. If two directions will come, there is no possibility of the same thing are going in the same direction. Suppose you are in the middle of a line and you wanted to go somewhere. Suppose you wanted to go from Haryana to Delhi. Okay, you cannot go from Haryana once you will start from Haryana and you are going to the Agra. This is the opposite direction, na? So there are two directions, but you are only you can only go in one direction only to the Delhi, not the other. Na? There is no way we can go Agra then come back. It is the biggest thing for us. So the next is electric field intensity due to a point charge. Suppose we have a point positive Q and we are letting anywhere a test charge, and the distance between that test charge is Q naught. Sorry, the distance between that test charge is radius R. Okay, and due to A, the electric field is going far from that, and it is making a line towards passing through P, passing through Q naught charge. Okay, so let use the Coulomb's law. We can understand that what is Coulomb's law. So Coulomb's law basically represent that the about the force. Okay, when two charges play, there is a distance between two charges. It is like a gravity, na? Gravity is G is equals to m1 m2 by r square. It is a similar thing. So if we are having F force is equals to K Q naught, Q naught, because Q is here, positive Q, and Q naught is the other charge, and divided by the square root of the radius between them, or a distance between them. It is a force. And now what we have learned about the formula of electric field intensity, it is a force per unit test charge. So just put the value of force and you will know the test charge value. So the final value of its E is equals to K Q naught over R square. And once you will cross those things, eliminate the test charge from it, you will get Q naught, KQ divided by R square. That's the proper electric field intensity that you will have. Thank you. Thank you guys having with me the Kunal Jangra with Urban Pro. And please be safe because the coronavirus is having, and due to that you will get harm. And whenever you wanted to learn with me, you can go through the Urban Pro and contact me. My name is proper Kunal Jangra. You can have my ID also from there. Thank you.